Good day. This is Group 8 from BSCE 1206, here to present our program entitled Surveying 101. For the overview, Surveying 101 is a program created in line with the course of Civil Engineering. This is a program that features three methods of surveying, namely pacing method, tachymetry method, and electronic distance measurement. For the pacing method, it is a way of determining distance using pace length. It is the process of walking a certain distance and keeping track of how many paces are needed to complete the distance. For tachymetry, it is an angular surveying technique in which the horizontal and vertical distances between 2 points are measured with a tachometer. Electronic distance measurement, on the other hand, uses electromagnetic waves to calculate the distance between two locations. For the pacing calculator, here is what it offers. It easily records the number of steps or pace that you've done to cover a distance. It is able to calculate the mean number of steps, which is also required to determine the pace factor. For tachymetry, it offers two options of formula for finding the horizontal and vertical distances. Lastly, for the electronic distance measurement, it uses camera as the primary instrument for determining the distance between the camera's face and the object. For the next part, here is Ms. Rabano to discuss the objectives.
For the objectives, we have the creation of this program aims to attain the following objectives. First, assist students, educators, and other concerned personnel for convenient methods of surveying, which are the pacing, the tachymetry, and electronic distance measurement. Second, provide accurate calculations for the three aforementioned methods of surveying. Third, allow users to have fun and experience a new way of surveying. And lastly, be a model or reference for the production of more programs or projects related to surveying. And to present to us the methodology, here's Mr. Ferreira.
Good day everyone. Let us now proceed to the methodology part of our program. We have used different functions and modules in our program. First, we have the break function. This is used to end a loop and proceed to the next piece of code comes after it. Next, we have the center function. This is used in the program to place the outputs in the center of the screen. Third one, we have continue function. The user can continue using the program if he or she wishes to, even if they has already used one of the methodologies by using this function. Next, we have the define function, used to define a function for storing data and to easily call out a function when needed. Next, we have the float function. This uses float function to convert the values to decimal or fractional numbers. Next, we have the for loop function. This is used to iterate over a list, tuple, or other types of data. Next, we have if-else function. This is used in making conditions as evident in the first section of the program, wherein the user were asked regarding what type of surveying he or she wishes to do. Next, we have import function. This is utilized to import modules to the ongoing system. Next one, we have the integer function. This is used in the program to convert values into an integer. Next, we have len function. Len function is utilized in the program to count the number of encoded trials in the first method of surveying, which is the pacing. Next, we have print function. This is mainly used to print the introductory statements and display data on the screen. And next, we have return function. This function ends a function call and gives the caller again the result. Next, we have the round function. The round function is used to round a floating number to the number of decimal places specified by the user, and in this case, we use 2 decimal places. Next, we have the sum function. This is used to find the sum of the steps per trial that is needed in finding the pace factor. Next, we have the try and except function. This is utilized to record the input of the number of steps in the basic factor. Lastly, we use the while loop function. This function continues to run while the aforementioned conditions are still true. That's all for the methodology of our program.
And with that being said, let's hop into the program Surveying 101. So as you can see in the first part of this program is to import colorama. This is to have the text design such as the color of the text for the Python program. And then over here we have the main menu of the program where you can choose whatever you want to do to compute in this program. And we have assigned this as a variable named wish over here. And yes, as you can see here, there are three calculators that you can use in this program. First is the pacing calculator, the tachyometry calculator, and the ADM calculator, or the electronic distance measurement, which has been discussed earlier in this video. So without further ado, let's hop in and test out this program. So we're just gonna click on run here, and then as you can see here, it says welcome to Surveying 101, and then there's the main menu. And let's say I want to test the pacing calculator because I have the problem here that says a 60-meter line XY on a level ground was paced by a surveying student for the purpose of determining his pace factor. The number of each paces in each trial is as follows: 73, 72, 72.5, 74, 73.5, 72, and 73 paces. Determine his pace factor. So I will try to select number 1 to solve for this problem. And it says here you selected option 1, and the enter the line meters as said in the problem is 60 meters. And for the number of steps, you just have to count the number of paces that he has made. There is 1, 2, 3, 4, 5, 6, 7. There's 7 steps, 7 paces. So for the first trial, he gets 73 paces. Then next is 72 paces. Next is 72.5 paces. Next is 74, followed by 73.5, and then 72 and 73 paces again. So there you have it. Your pace factor is approximately 0.82 meters per paces. So pace factor. What is pace factor? It is the ratio of the measured distance in the number of paces made by the individual to cover the measured distance. So yes, we were asked here by the program, do you wish to continue? Press 1 if yes. Press any key to exit. So let's say I want to try the other parts of the program. Let's say press 1, and then we are back in the main menu. Let's say I want to try out the tachyometry calculator. So we're gonna press 2. Okay, it asks me again, which one do I want to calculate? The horizontal or the vertical distance? I have here the problem. You have gathered the measurement needed to calculate the horizontal and the vertical distance. You have known that the angle is 12 degrees and the slope distance is 6 meters. So in this problem, we are to identify that both the horizontal and the vertical distance. So let's try to identify first the horizontal distance. Say it's 1, and then there's another formula here that says, there you go, the distance for horizontal distances. So in this problem, I only have the vertical angle and the slope distance. So we're just gonna use this, the first formula. So enter number 1. Okay, so the vertical angle as said in the problem is 12 degrees. And and then the slope distance in meters is 6 meters. So there you have it. The horizontal distance from the person to the surveying is 5.87 meters. And so we have here another set of formulas for the vertical distance. And since in the problem we only have the degree or the vertical angle and the slope, so we're just gonna use this first one. So we're gonna type 1, and now the vertical angle, as said in the problem, is 12, and the slope distance is 6. So here you have it. The vertical distance is 1.25 meters. And what if we try to use the second formulas in vertical and horizontal distances? So let's have this problem. After collecting the needed measurements, the measurements that you have are as follows. The top reading is 3.75 meters, the bottom reading is 1.125 meters, and the vertical angle is 12.5 degrees. The multiplying constant is -100. Then calculate the horizontal and vertical distances. First, test out the horizontal distance. So let's say 1. And for this, we already have the multiplying constant and the intercepts, or the top and bottom reading. So we're gonna press 2. The multiplying constant said in the problem is -100. The value of the top reading in meters is 3.75 meters, and the bottom reading is 1.125 meters, and the vertical angle of 12.5 degrees. So the horizontal distance for this particular problem is 12.49 meters. And what if we want to test the vertical distance? So just gonna press 1 and then tachyometry 2, and now we want to calculate the vertical distance, let's say 2. And from the same problem, we have the multiplying constant, the top and bottom reading, and the vertical angle. We're gonna press here. So the multiplying constant once again is -100. The value of the top reading is 3.75. The bottom reading is 1.125, and the vertical angle is 12.5. Now, as you can see here, the vertical distance is 54.83 meters. So there you have it, the tachyometry calculator. So what if we want to try the electronic distance measurement, or the EDM? So we're just gonna press 1 to go back to main menu from the last program that we had, and then we're gonna press 3 for the electronic distance measurement. Say 3, and you selected option 3. It should open up a camera, and let's just wait. Oh, there you have it. Now this is the reference image used, and this is the camera. Here you have it. And the distance that says here is the distance of me from the camera. That's what you can use for your surveying as your distance. So there you have it, guys. Let's press Q to quit. So there you have it, guys. That is the surveying 101 by proximity. I hope you learned something from this video. I hope you enjoy it, and please remember to always take care of yourself, and goodbye.